We've got an abridged version of the Brush Your Teeth project, so we can have a bit of a play around with referencing existing infrastructure, things that either don't exist in CDK or exist in a separate CDK project. The first technique we're going to have a look at is using a static method on the construct or type of thing you're trying to create, and then filling that with values from some source and then using it in another construct in some properties. So let's have a look at the Lambda function here. And if we wanted to put this Lambda function in a VPC, we would provide it with an ec2.ivpc, just an interface for a VPC type. And there's also a little bit there hinting at the fact that we might want to select a custom set of subnets for our Lambda. But we're actually going to rely on the default subnet selection or the default subnet selection behavior. So we need a VPC. Where do we get a VPC from? Let's pop to the top of this method here. Let's create that VPC variable, and then we can do VPC.from VPC attributes, which is a static method on the VPC class. And let me give that an import. And then we give it the usual 3 arguments, so the scope it's being attached to, the logical ID, and then some form of properties. And if we look at the TypeScript error here, there's only 2 properties we actually have to provide, VPC ID and availability zones. But the full list of all the properties is huge, and you might be thinking, oh my word, do I really have to set all of these values? And the answer is that no. The answer is that sometimes you'll have to set one or more of the values, but it really depends on where the construct's going to be used, what we're doing with this VPC. So if we provide these 2 values that we're required to by TypeScript, the availability zones and VPC ID, let's see what happens. So I'm going to pop to the console. I'm going to grab the VPC ID of the VPC we got for testing. I'll pop that in here. Whoops. And then we're only in 1 availability zone in this VPC, I think. So let's go and have a look at the subnets. What availability zone are we in for our private subnet? EU West 1A. Okay. I'll grab that from the name there, pop that into our availability zones, and we'll try a synth. So we get an error there, and it's a bit of a confusing one. It says there are no public subnet groups in this VPC, available types, and then it's blank. There's nothing. You might be thinking, well, what on earth's going on there then? And this is to do with the subnet selection that's going on. You can see actually in the stack trace, we're talking about choosing particular subnets for our Lambda function. And you probably know if you use Lambda that we can't really use Lambda in a in a public subnet. It needs to go in a private subnet with a NAT gateway. So we want to provide the Lambda function construct here with the subnet or subnet IDs that we want it to put the Lambda function in. So let's specify those, and we're going to use the private subnet IDs property. It might take you a little bit of experimentation to find the right properties that you have to provide, but I recommend sort of going through cycles of trying it with the minimal properties, running a synth and seeing which values are actually used or aren't used. So let's grab our subnet ID there, let's paste it in, and then we can run another synth. Okay, much better. So the synth did succeed, but we got a warning. The warning is that we're looking up the value, so we've got our lookup example stack, VPC private subnet 1, no root table ID was provided to the subnet, and then our subnet ID. Attempting to read its .root table ID will return null undefined. So here's a bit of a warning that we are building up a very rich object with many properties, but we haven't provided all those properties. And it's up to you whether you care enough about the warning to do something about it, or whether you just want to leave it as is, because it will work for us even with that warning in place. But you might say, do you know what? I don't want that warning. I'm not really keen on that. So we could go and have a look if there are some properties related to that, and we've got private subnet root table IDs. So let's pop that in there. Let's go and find the root table ID for this subnet. Here we go. Here's the ID. Whoops, if I could copy and paste, that would help. And we'll pop it in, and we can rerun it one more time. Lovely. And now we've got no warnings, and still the synth succeeds. So let's go and have a look at our Lambda function in the template.yaml. So we've got the usual stuff. We've got our code, got our role, architecture's environment. These are all the same as they were before. And we have a new property here. We have our VPC config, and that's got a security group and a subnet. And you could have multiple subnets, obviously, but we've just got one subnet for this VPC. And if we go and have a look just above these bits here, then you can see the security group that's been created, and that security group has been placed within our VPC. So these were the two bits of information that it really had to use today for this one use case we've got, was the VPC ID and the subnet ID. So we didn't have to specify things like the public subnets or public route tables. We didn't have to provide all of these properties, but we did have to use a bit of savvy to know how this construct was going to be used and what properties were going to be getting pulled through. So that's one method. It's using a from method, which is a static method on the construct you're looking for. And some of them, it's very simple. Some of them, there's only one property. It's not a huge list of things like the VPC construct, but it really varies on the use case. So let's look at a bit of an alternative. Let's see what else we could use. So another type of lookup we could use, or another way of doing this, is the from lookup method. And this isn't universally available on all constructs, but we can use it here for a VPC, and you can use it in a number of cases. And then this time we actually don't have any TypeScript error at all when we call this. We haven't been asked to provide any types by TypeScript. So let's look at from lookup. Let's go and have a check of the VPC lookup options here and see what we can provide. So we could look at a name, we could look at an ID, we can look at tags. So there's a huge number of things that we can use to find the VPC. It's a very flexible option, which is really, really nice. I think in this case, we'll just use VPC ID. So let's pop that in there. Let's grab the VPC ID we used from our other example, and then let's run the synth again. So that's completed, and it did take a little bit longer. You may have noticed that that was slightly slower than the other version. And the reason for that is it was looking up the VPC information. So if we go and have a look in our cdk.context.json, we've now got a great big object with a load of data about the VPC. So we didn't have to specify this, didn't have to specify the CIDR block, didn't have to put the owning account, we didn't have to say that some subnets were public and some subnets were private, didn't have to look up the availability zone. It's gone and gotten all this information for us, which is really convenient, and it's plopped it into our CDK context.json. So that's one thing that, if available, is very, very handy. Obviously, you've got to go and look these up for all accounts and all regions before you commit your code, and make sure you do commit your CDK JSON, CDK context.json, but just something to demonstrate a slightly different approach. So there was two examples. One was creating the construct from a set of values that we know about it, and choosing the right values based on how it was going to be used, which constructs were consuming that. And the other one was using something where we have the option of using a lookup, where CDK goes and fetches that data before we do the synth, or as part of the synth process. It plops it into the CDK context.json, and then it's available for all future runs. It doesn't have to look it up now for subsequent runs. So you might then be thinking, well, okay, that's some methods of referencing some existing infrastructure, but how do we get this VPC ID? Where does this come from? Obviously, we could put this in the context if we wanted to, but then we've got to go and manually get those values and put them in the right place. But we might want to reference another project. We might want an easier way to do that in a more automated fashion. So we're going to look at two ways to grab these values from an existing source. So let's comment this lookup version out for now, and let's grab the original VPC version, and we're going to create some SSM parameters. So here we are in the SSM console. So let's create these. I'm going to choose a prefix of our liking. So we could say this could be a lookup example, and then let's just pop in the same key we've got here. So availability zones needs to be a string list, because we can have many availability zones. Let's create that. VPC ID can just be a normal string, because there's only one. And of course, we're making these manually, but you could make them with a different project. Another CDK project could use the the string parameter construct to actually produce these and put them into your account. Same thing for private subnet IDs, needs to be a string list. And then finally, we have private subnet route table IDs, and that needs to be a string list as well. All right, so we've got our parameters. Let's copy this version we've got here with the from VPC attributes, pop it down here, and then we'll pop some variables in to look up our values. So for availability zones, we're going to use string list parameter because we've got a string list. And then we want to have a look at this class, and here's the value for typed list parameter method. So we're going to use the current scope, and then the parameter name needs to be the same one we've got in the console. Pop that in there. And then optionally, we can provide a type for the thing going into here. So I'm going to say that this is a parameter value type dot EC2 availability zone name. And then we can repeat the same thing 3 times for the other string lists. So we've got our subnet IDs and our root table IDs. We can change this to be a subnet ID. I don't know if there is one for the root table actually. Let's have a look. No, there's not one for the root table, so we'll leave it as the default. And then we need to change over the parameter names as well. VPC ID is a little bit simpler because there's just one thing to look up. It's not a list, so we'll do string parameter. And then there are quite a few methods on this string parameter class, so it can be tricky to find the one that we want to actually use, especially when my IntelliSense is playing up a bit. But we're going to use value for typed string parameter v2. And then we can use this and the name of the parameter. And then the key there, VPC. And then finally we can give it a type again. So let's pop in parameter value type dot VPC ID. All right, and now we've got that, we can, oops, sorry, this should be VPC ID, not VPC. There we go. Now we've got that, we can change out these static values for the ones we've got in those variables above, the ones that are going to be the lookups. And then let's do a synth and let's see what this looks like in a CloudFormation template. So we get a few warnings again, but they're fine, we're not too worried about those. And you can see at the top of our template here, it's actually produced some CloudFormation parameters. And you can see that they're all typed with AWS SSM parameter value at the start. And then we're getting a list of things in 3 cases, and then the inner type of these values. So if you were to go and look at these in the console, they're linked up to an SSM parameter. And that's why the default here isn't a default value, it's the parameter it's going to go and look these up from. So it can be a little bit confusing because you might think, well, that's not the value, that's the name of my parameter. But because we've got this SSM parameter type here, it's going to go and look it up. So one of the challenges with this approach is that we can't see the values up front. We can't see them in our template. So we have to try deploying this, and then we'll get whatever is the right thing at deployment time. And that might not suit your preferences. You might think, well, actually, I would prefer to see the actual resolved values first. And very much in the same way we did with the VPC.fromLookup method here, there's an alternative for the string parameters with a lookup. So let's have a look at the string list parameter class. So unfortunately, string list parameter doesn't have a lookup method, but when we use a lookup, we're fetching the value ahead of time. We're fetching it before the template is synthesized, and so we can manipulate the value in TypeScript. So we can actually use a method on string parameter instead. So let's change this availability zones over here to string parameter, and then we would like value from lookup. Here we go. And that takes in 2 arguments instead of the 3 we've had before, so there's no type now. And then what we need to do is once we've got that value from lookup, we need to split it with a comma. And that's going to look very much the same for the other stringy value, the listy values we've got. So let's do that one. We can add the split in. And we can do the final one, the root table IDs, and we'll add the split in again. So I'll give that a format, and we can change over our VPC ID as well to value from lookup, and there's no split required there because it's a string parameter, not a string list parameter. So let's give that a run. And now we can see that in our template.yaml, we have the real values present. So the security group ID has the real VPC ID, and the Lambda function has the real subnet ID. So if you run a CDK diff, this approach gives you the actual value and lets you know if it's going to change. And if we pop into our CDK context.json, you can see that these 4 values have been looked up. And we only have a single value for our list parameters, but it does work with a string list where we've got the comma separated ones. So that's SSM. That's some example methods of how we can look up parameters from there. What about Secrets Manager? And the first thing you might be wondering is, well, why would we use Secrets Manager for some of these kind of values? They're not secrets. And one of the advantages of Secrets Manager is we can give them a resource-based IAM policy, and that means we can allow cross-account access or even access between any account in the organization. So let's change our VPC ID here over to a Secrets Manager secret, just as a demo. So let's pop Secrets Manager, go to Secrets, we can create a new secret. It's just going to be an other type of secret, and we can go to plain text here, and we don't want JSON. We would just like the VPC ID. So let me see if I can grab that from the code and pop that in there and go to that next. And then on the page here we can put a name in, so we could give it I don't know, lookup example slash VPC ID. Give that a next and a save or a store. Give that a refresh, and there we go. There is our secret. And then if we go to the setup here where we've got our VPC ID, let's change that out for a Secrets Manager secret. So we can do const VPC ID equals secret. Whoops, let's import the right one from Secrets Manager. Dot from secret attributes, and then we can pass in the current scope, which is going to be this, the ID, which can be our VPC ID, and then some attributes, and we're going to use the secret complete ARN here, but there's a variety of options you could choose, including ones for secret name. And then you can see that it's now not an appropriate type. We've got an iSecret instead of a string, so we're going to do VPC ID dot secret value, and that's a secret value. That's still not a string. And then we do unsafe unwrap, and you might be thinking, oh dear, that's not very good, is it? Unsafe unwrap. And the reason we're doing that is because we want to turn the secret value that's trying to, you know, that CloudFormation is trying to protect, trying to keep safe, and put it into a resource directly. So we won't see it in the template, but we will see it when that resource is used. And obviously, if that was a database password, we don't want the database password, say, attached as an environment variable. We want a service that is consuming that secret or consuming that password to look it up. So it's not stored somewhere you could just go and have a look in the console unless you actually had permissions to see the secret itself. But it's okay because this is just a VPC ID. We're just using it because of the fact that Secrets Manager supports resource policies. Okay, and let's give that a synth. Lovely. And then in our template, we can go and find where the VPC ID is used, which is in the security group here. And you can see we've got this funny resolve syntax where this value will be passed to CloudFormation. So we obviously can't see the value up front. We can't see it just after the synth stage. But when it gets deployed, CloudFormation will take this token here and turn it into the real value. So there's a bit of an example of using a Secrets Manager secret instead for a value lookup. So we covered a few different approaches for referencing existing infrastructure. We used a from static method on the construct of choice, in this case a VPC, but many constructs support these kinds of lookups. We experimented with what parameters we had to provide and based on where the construct was being used and the downstream components, if you like. We also experimented with a lookup style method where instead of having the object constructed from a set of parameters we give it, we get a much richer piece of functionality where we can look up the resource with a number of methods and then it gets stored into our cdk.context.json. For finding the initial values used for something like that, we then experimented with Systems Manager, both with a string parameter and a string list parameter. Obviously we've changed this now over to lookup, but we originally had the string list. And then we also saw that if we didn't want that kind of method, if we wanted to see the values before we get to the deploy stage, then we could also use a lookup on the string parameter. And because we've got that value at synth time, if you like, we can do TypeScript operations on it, like a split. It's not one of these funny tokens that CloudFormation will receive and then translate at runtime. And there we go. There is some examples of referencing existing infrastructure.